I had some questions about how to create a raster legend that you can import and use later because the interpolation exercise that we did gave you a layer file already with that legend created. I'm sorry, the symbology created. So here we are looking at some carbon monoxide data, air pollution data from 2020 and 2019 in where are we? In Los Angeles. And what we want to do is have the same legend so we can see the details and how it changed from 2019 to 2020. So one thing you can see that is a great place to start is opening up your classification and looking at the histogram. So understanding where the lowest value for your data is and the highest value, and thinking about how these classes are all created. If we go over to our second set of data, we can see that our lowest value, again, is 0.175, so pretty close. But we have, if we look at our legend, despite having a similar lower value, we have different upper values. So we also, all of our classes are slightly different, so they start on different numbers. So our challenge here is figuring out the best legend to use. We can, like you do with vector data, use the different classification schemes and different methods for classifying your data. If we wanted to create a legend that would work for both sets of data, it might be easiest, just like your vector data, to go into the manual legend and start modifying our class breaks. One thing that's important is our lowest value should be the 0.175 and the highest value should be 0.54. So the challenge here is if we want the 9 classes that we have in the standard symbology, the values between the values for each classes will be different, and we have to figure out how to calculate the best spaces between them. Okay, so to get back to our geometrical classification, it's actually a more complicated formula, so we'll keep it simple and say we're just going to display our 9 values in equal interval classification. So this divides the range of our attribute values into equal size subranges. So this will call out high values and low values. We may have some empty classes, but I should tell you, our ranges of our attribute values are 0.0751 to 0.1751 to 0.545, etc. So I subtracted 0.01. I subtracted this value here from our highest value here to get the difference between the two. This is our range in values, 0.37, etc. I then divided that by 9 to come up with the 9 classes whose range between the classes is going to be this 0.4. I then simplified it, which I'm realizing I should have done it differently, but let's change that. Then I started to create, I created my 9 classes and I used my Excel calculator to do that math, which is this original, our lowest value, plus this value here, our range, our class range. And then I used that formula and just dragged down, oops, did it wrong. Let's start again. So then you can use that formula. You can say this value plus our range, and then we can see this actually calculated out. So now it seems to have worked. But we have each class, the upper end of each class. So this is going to be, the lower end will be our 0.175, and the upper end will be this value. It looks like we're a little bit short. I wonder if I did the math wrong. But we can add on a 10th class just by repeating that formula, and that will get us into that 5.45813. Then what we do is we go into our manual intervals. Let's do this. Then we go into our symbology for our 2020 data. Under classify, I change it to manual intervals. And what I need to do is start changing these upper values on the classes. I may need to add a class, which we'll look at in a second. But for upper value, we now want it to be 0. I'll just copy and paste this. I'm like, that's a long number. So we'll paste that in here. We can copy and paste. Now the trick is this is going to bounce this higher value further down. So you want to keep pasting in the correct order. So we're just basically, it's going to get a little bit confusing, but keep pasting your values into that the first cell here, because it will retain the symbology. We can always change the symbology, but for now we're just going to try to keep it pretty straightforward. So don't try to bounce around and find the space underneath yet. Okay, let me pause it. Nope, didn't want to unpause it. All right, so at some point your values are going to start being in the right location. So this 0.23 is no longer one of our upper values, so we can just paste in there. It's going to get a little bit confusing because I decided not to pause it. Copy this value. We are going to go Okay, so now we have our, that's not right. Okay, so 2, okay, upper value is 2.1. Okay, so this is correct. This lower value is incorrect, but that's just a label, so we can change that to point. What do they make that point? Wait, hold on. We're going to come back and fix the labels. Right now I'm concerned that these upper values are correct. I'm going to fix the lower values soon. Like, this is clearly not right. This is a label. This will have no impact on how your data is displayed. Let's fix that so we can start to see how it's changing slightly. To add a value, so here you can see our equal intervals, equal length classes. We are going to go in here. We are going to insert a break. And then instead of this, wherever we randomly placed it, we are going to change it to our upper value, our last upper value. And we're not seeing it on our histogram because we don't have any values in that histogram. But if we go over here, we don't see it either. Where did it go? Hang on. Okay, what I had to do was on the histogram, I clicked on this bottom value that it won't let me click on it now. It might just be frozen. I clicked on the bottom value and changed it to our value here. And then you can see that we have our second 0.5375 here. And then when we go over here, we can change all of our labels as needed. So I'm going to change these labels, manually change the labels. All right, I've gone through and edited all the labels. The other thing you'll notice is that this is where my 10th class went. It ended up randomly in here. So I'm going to change this value, maybe not randomly, but that's where I put it on the other, on the histogram. I'm going to change this upper value. Okay, just give it a second. And we'll change this to 5376. Oops, that's not right. Oh, shoot. Okay. 5376. You'll see the color is a little bit out of order. Remember, we can change the color scheme and also just select it again. Which one is it? So we can see now that I just reselected that same, roughly the same color amp and just added it back in. Oh my goodness, this video is getting long, but here's your last step. So I'm going to save my project. I'm going to right click and click share, save as layer file. Make sure it gets into the project we're working on. Okay, nothing's going to happen, but we'll go here, we'll turn it on our 2019 data, we'll click on our sandwich button, import from layer file, go into our folders, use that carbon monoxide symbology, and they should, and they do, match up. So let me make this bigger. We can now see, we can compare like to like, so we're comparing the exact same thing. Our legends are the same. We can compare like to like and see where carbon monoxide is high in 2019 and then how in 2020 the values shift. And that is how you create that matching legend for two sets of raster data.